Good day, everyone. Thank you for your time, and thanks to buildingSMART International for this opportunity to introduce you with workflows in integration with openBIM cloud-based environment using our BIM platform. My name is Mileta Pejović. I'm Senior BIM Manager at Bexel Consulting, and I'm a member of BSI Professional Certification Program Development Group. This presentation is dedicated to our latest Bexel Manager workflows in synergy with cloud-based solution, and I will only have enough time to briefly introduce you with these new solutions that we are developing as a part of a bigger integrated cloud-based Bexel Manager cloud ecosystem. What we wanted to achieve by integrating Bexel Manager workflows and new cloud-based solution is to establish a cloud-based single source of truth, and that user can access and manage project data, but at the same time to publish and share all relevant information using our Bexel Manager online services such as Online Viewer, Online Power BI reports, and Portfolio Manager. Finally, we want to present our crucial information in a way to allow all project participants to clearly visualize and control all key project indicators using interactive dashboards. Our goal is to utilize integrated BIM data so that produced information is already presented in our integrated BIM model in the best possible way. Our open cloud-based solutions will allow you not just to read this BIM information as professionals or experts, but to also present information in a very direct and easy way to all stakeholders in the project that doesn't necessarily need to have a training or experience in advanced BIM application and advanced BIM management tools to understand and use. If you're not familiar with the Bexel Consulting, we are an international software development and consulting company specialized for BIM in construction. We have experience on very different projects around the world, and our company is multinational member of buildingSMART International. We are devoted to BIM implementation, BIM project management, education, and innovation in BIM. 2 years ago, our company won Innovation Award at buildingSMART annual competition, and this year we are one of the finalists in technology category. We are very proud to be recognized as one of the leaders in innovation in field of BIM. Besides integrated BIM within different software solution or its modules, it is also really important to use the advantages of emerging technologies like cloud-based environments and systems. This means that federated BIM model, which is at the core of integrated BIM process, should become a cloud-based single source of truth. This source of truth will enclose all information from all stakeholders, keep it online, always accessible, in safe storage, and allow very easy and very quick exchange of information in a new collaborative environment. As you can see on this slide, this is the current Bexel Manager ecosystem map, which is evolved past years, and we can read data, we can import information from a range of authoring tools using openBIM formats. But now, not only that all of this information and different sources of BIM information could be federated within our desktop-based application, but also directly in the cloud environment. That means that all information not only could be exchanged between stakeholders in we can call it internal or desktop exchange, but with the respective user administration, it can also be done using mobile devices, online, from the site, even without need to use desktop platform. All the information that is concentrated in the federated BIM model as a single source of truth now could be accessed and exchanged through a collaborative process using cloud-based common data environment, which includes services I will presenting today. In essence, the core of the system is still Bexel Manager desktop application that includes federated BIM model and BIM analysis modules, data validation, clash detection, quantity takeoff, cost, smart 4D and 5D scheduling, progress tracking, and reporting that are now set up in a new collaborative data modular environment, which eliminates major obstacles for proper communication between different project participants. Through a further development, Bexcel Manager platform gets its bidirectional communication processes with the cloud-based solution, which enables this rich database to be accessed directly by project participants without need to use the platform itself. A simple web browser becomes a gateway to integrated BIM data through Bexcel Viewer and Bexcel Common Data Environment. All model elements, selection sets, custom breakdowns, 4D simulations, and even progress tracking information are being shared with other stakeholders, but also information is fed to Bexcel Manager desktop platform as well. All the data and analytics available within the BIM model is utilized through interactive Power BI reports, which connect data and model elements. A complete so-called portfolio of all projects is managed through an incremental database of key project indicators precisely measured by BIM software and regularly updated to cloud-based portfolio management platform, where it could be properly presented and analyzed by relevant stakeholders that doesn't need any training for expert BIM software, but can easily benefit from all information that online system can deliver. This new approach allows not only full utilization of BIM data, but also easy integration of BIM with third-party systems and databases like ERP system through Bexcel Ecosystem API. And of course, all this is managed and controlled through clear user management and access control protocols, which ensure data safety. Today, I will present workflow and uses of our main cloud modules of integrated cloud-based system, Bexcel Viewer embedded within Power BI, Online Model Viewer, Bexcel Common Data Environment, and Bexcel Portfolio Manager. Bexcel Viewer, as an integral part of Bexcel Common Data Environment system, is a cloud-based application that allows project stakeholders to access model data without a need to use desktop BIM platform, and it is also an essential tool for linking data and geometry in Bexcel Cloud environment. Some of the main features of the Bexcel Viewer are IFC support and point cloud integration, review of large-scale BIM models and project data, color-coded custom breakdowns, and flexible element grouping structures that can be updated as well. Exchange of BCF or annotation files between stakeholders, clash detection review, 4D schedule simulation in the cloud, advanced integrated progress monitoring workflows in both directions. It means that from desktop BIM application to the site and from the site back to the integrated BIM model as well. The entire environment could be also hosted on either client servers or on Bexcel data centers using MS Azure around the world. Bexcel Portfolio Manager is also a part of Bexcel Common Data Environment system, but the main purpose of this service is for management of a full portfolio of projects. It stores key project indicators of all versions of projects within single organization, and its main purpose of this, let's say, service is to give users or project investors an overall picture and to allow cross-project analytics, and by that also to enable quality control of projects through detailed KPI analysis. Together with the detailed Power BI reporting system and its integration with cloud-based application, the whole system is envisioned as a BIM command center that allows to multiple projects be managed, successfully reducing possible risks to minimum. This command center allows digitally driven construction and focuses on the essence of the construction management process, so key project indicators like actual cost and earned values, cost performance index, schedule performance index, and all these essentials data are now instantly calculated and easily available and verifiable from a credible single source of truth. One of the greatest advantages and benefits of this ecosystem is that everything is accessible and tangible within that one single source of truth containing all relevant information and allows different users to use and manage the one information that are necessary for their current scope of work. So in our case, as Mr. Ando mentioned today, it is really not important terminology or definition of 4D BIM or 5D BIM. Using this approach and our system, all information related to model itself, information related to cost and estimation, as well as all scheduling information are available, and at the same time you can use it as required. Now I would like to guide you through the entire process step by step from the beginning, and we are creating a new project. The initial version of this project and its revision will be created, and we are selecting multiple IFC files that shall be federated into one BIM project. One of the most important things, especially in the early stages of project, is coordination and collaboration of all project trades, and therefore frequent and progressive clash detection analysis performed on a project and are extremely valuable. Our workflow allows you to almost fully automate entire process by using our customizable templates for performing clash detection process, and at the end to explicitly and clearly present all results of analysis using interactive Power BI dashboards. First, we need to create some selection sets and organize BIM model elements into specific groups that shall be used for clash analysis. Here you can see a list of different templates for creating smart selection sets, and these are commonly used and can be reused on almost every project. In this case, I will use the one called Clash Selection Sets Sample Basic, and before loading it, I just want to explain how these templates file work and how you can customize them. On the left side, you can see the column which represents the location of your selection sets and in which location your selection set will be saved. The second column, which is called name, represents the name of each selection set. And the last column is called query, which representing rules that are used to create smart selection sets. These can be really simple ones as this one, for example, for doors, just telling the system to select all IFC entities or categories of doors and put them in one selection set. Or we can make some more advanced selection set rules combining multiple IFC entities and respective properties that will be used to group elements in a more delicate way. Once we import selection sets, the system gives us information, and you can see that all these folders and entire folder structure containing selection sets is imported, and these groups are matching with the ones that we specified in the Excel file. All names and the folder structure is exactly the same. Similarly, as we imported element groups organized by trades used to find collisions, we can also use available customizable templates from our knowledge base, and this knowledge base is at the moment local for each user, but very soon we plan to make this cloud hosted and available for all our users with respective credentials. These predefined clash detection jobs are based on common BIM clash matrix, and you may see how this Excel file looks like. On the left side again, we have the first column with a list of clash detection jobs by different names, and we also have included severity of clash detection in their name. First, second, and third priority of the clashes, and in the columns for the left and right clash detection groups, we are specifying which selection set will be checked versus different selection set for collisions. And in the last columns, we are specifying clash type and tolerance if it's needed. Once we decide or create wanted template using the option open, these clash jobs will be imported in our system. You can see the list of imported clash detection jobs, and you see that the current result is currently 0 because we didn't run it yet, and now we can decide whether to run all clash jobs or only selected ones. Once we executed this command, the system checks collisions between elements and creates result for each of them. The speed of clash detection analysis is affected by hardware of your computer and also by number of different elements included in projects. So once it's completed, you can see the total number of found issues. It's almost 15,000 clashes between different types of elements. And as is similar platforms, all results are listed and the user can go through each found result in the viewer just by clicking on it. For each found issue, we may see which element is included and what is the location of collision in the model map. If we want to organize and group these clashes into multiple groups, the system also have option for automation, and we can instantly group all the clashes that are including the same elements. In this case, I will use the option to group by left side, and as a result, the system will group all beams that are clashing multiple HVAC ducts and pipes multiple times into groups, grouping each beam with multiple collision with different MEP ducts into one group. So now you may see that each group contains one beam colored in red and several ducts colored in gray that colliding each beam. All found clash results can be also organized into BCF files or exported into PDF, HTML, or Excel spreadsheets that are pivot ready and useful for progressive reporting of your coordination process. But to elevate the quality of created reports, we enabled the export of clash detection analysis into interactive Power BI reports with an embedded model viewer. So to streamline the process of embedding the model viewer into Power BI, the steps are really simple and I will just show it. User just needs to export the current Bexel Manager 3D project into an online viewer using Publish to Online Viewer option and select options that are according to our preferences. We can even choose whether to export all model elements or just specific ones. And we can also divide or organize BIM elements in our viewer based on IFC model sources or by selection sets or BIM categories. Once we decide, we can just click to the publish and the system will take some time to export the entire project depending on the size and also based on the number of BIM model elements and their complexity. And of course, based on the internet speed as well. So once it's completed, the system will give you information with a web link to access published 3D model online. And if you're not logged in, you can log in to your account, and based on credentials, user can access different online models or projects. Once you're logged in, on the left side, user can choose which models and sources they want to load in the viewer. In this case, I will load all, and as you may see, the system currently opens all sources of exported file, and we can just review 3D model using any web browser or mobile device. All properties related to selected elements or to 3D model elements are also available on our viewer, and you can see all the properties, all the values of all these properties of selected elements. Since we also have exported selection sets from our project, we can see the list and the entire hierarchy of these selection sets, and we can use this hierarchy to select elements or change their visibility, similarly as we could do that in our desktop application just by clicking these visibility indicators. Another useful feature here is the ability to share exported online model with other participants, so you can just type in email address of other users and there will be receiving notification with the same online link so they can open it or review it by themselves. Of course, they also need to access rights in order to use it. So once we have, or since we have this exported web address, we can copy the link and use it to our Power BI report. So the next step is to go to Bexel Manager and use publish Power BI report and paste this provided web link to our online model. During this process, user can choose which clash analysis they want to export, and once the exporting process is completed, we can open Power BI report using a Microsoft Power BI desktop application and edit visuals, charts, or even we can change the language if it's required. I will skip this step and I will just show you the final published Power BI dashboard. This one is free and it's available as out-of-the-box template, so anyone who have access to our online viewer can use these visuals and link it to any 3D model they create, and they can also use their own Power BI reports and adjust it to according to their needs. As you may see, the entire 3D model view is loaded. All 3D source files, since I checked that option, are automatically loaded. And on the right side, we may see the list of all clash detection jobs. And since everything is interactive, once you select any of these clash jobs, the lower table will show you all these results, each instance of issues, and directly in 3D view, you may see all these found issues distinctively colored in red and green color, so you may easily identify elements which are in collision, as shown in these tables in the corner. In the lower part of this Power BI report, you may see that all issues are organized according to buildings and building levels, and in the middle, you may see that all found issues are also organized by different BIM elements. The slider on the left side can be used to filter down specific clashes based on the penetration distance between elements. These templates are free and available out of the box, but as I've said, if you have Power BI desktop application, you may create your own templates, you may change their look, you may change information you want to show, and also the process is just straightforward. You don't have to do anything additionally to have model view connected to relevant data because everything is already connected. You just have to publish your Power BI report. Another extremely useful and new way to publish and share not just clash results, but all relevant project information is using our cloud-based portfolio manager. It's a unique online platform that collects all BIM data from multiple projects and multiple revisions of any project. All data is saved on a cloud-based common data environment, and published information can be stored in cloud-hosted database or on a client premises. To use the portfolio platform, a user needs to be subscribed to this service and use credentials to log in. With the respective access rights, you'll be able to explore projects and information based on your credentials. Results related to clash detection analysis can be found in this drop-down list, and predefined charts for multiple revisions of one project look like this. The platform is highly flexible and it gives you ability to rearrange and reorganize these charts according to your needs. For example, you may track how the number of clashes was changing during different project stages and in a different model revisions through time. All clash charts can be exported into PDF, images, or Excel files, and this platform can be accessed using mobile devices as well. The next step in the workflow is BIM data management, and Bexcel as an integrated BIM platform allows experts to manage and inspect BIM data using advanced BIM data checks. The entire process is automated using add-ins for IDS verification. Based on predefined check rules, the system can analyze if all BIM elements have added mandatory properties required for each project stage. These property checks are based according to international standards or according to any project information delivery specification. To execute the process, I will use add-in called Property Model Checker, which can perform these automated BIM checks. User can choose which file will be used for defining BIM check rules, and the file used for BIM check definition is usually Excel by default, since common users are familiar with Excel files and can easily change them. but we also have the option to use JSON files as well. Using import option, we can import some BIM check templates, and very soon these will be part of our free online knowledge base. So now I want to explain how this template file works. The first sheet gives you information how to specify and create your rules. The second sheet defines project stages in which required property should be populated. You may add as much stages as you want. Category name property is the place where you can set what shall be used to define various properties in each sheet. Commonly used option here is category, and then each sheet will be considered as a different category containing required properties. Project naming convention sheet is the one where we can specify naming convention and pattern for naming BIM files, for building name, and for name of each building story, if there are any requirements related to that. Property naming convention sheet is the one where we are specifying or setting up naming pattern for different BIM elements or IFC entities. The first column is used to set different entities, and the second one is used to specify naming pattern for each of them. In the property name, we have to set which property shall be used to check naming pattern, and in our case here we are using IFC object type property for that purpose. Pick list sheet is used if we want to predefine specific values for any property and to specify all these allowed or requested value for different properties. Finally, each sheet here represents different IFC entity, and in each sheet we can set required properties, property type and property set in which these properties should be placed. For each property in the column phase, we can set in which project phase the property should be added. On this specific project, I will use slightly modified template file. Naming requirements are almost the same, but required properties are slightly changed, and as you may see, each entity should have additional property set called required, and in that group a lot of required properties should be also populated. Once we load Excel template, the system will show us the list of recognized categories or IFC entities in the project, and we can now select for each project stage we want to check properties. Each BIM check can be executed separately, or multiple checks can be executed simultaneously. Also, you can execute selected BIM checks for selected elements only, and results are visible instantly. By using option evaluate, the system will execute all BIM checks for all elements, and after its completion, user can decide whether to create selection sets from these results or to export results to Power BI reports. It can take some time to system to execute all BIM checks, and again everything depends on the number of properties that are required and number of the elements which containing all these requested properties. You can see how results can be explored, and also using the option create selection set, we can create selection sets of all these results or publish results to Power BI reports directly. By creating selection set for all results, the system will make all selection sets containing all found issues, and these issues can be addressed directly to BCF files just by drag and dropping option from selection set folder directly to inbuilt BCF manager. So by doing that, we can inform responsible participants or design teams to resolve these issues. And this can be done for one or multiple selection sets at the same time. BCF files can be saved locally, or they can be communicated directly using online cloud-based platform. Now I will publish the results of this analysis to our portfolio platform. The system recognizing the project, and the revision will be also automatically and incrementally added online. When we go to web platform, you will immediately see updated published information. For IDS property checks, initially chart looks like this, so we can see the number of found issues is different in two different revisions of the same project. Visuals can be changed, and we can see property check results between version 1 and version 2. Or we can just switch these tabs and reorganize charts. Also, we can do the same thing for IDS or BIM checks by percentages. And of course, this type of charts can be linear, or we can change it to bars. Change visuals if we want to see, for example, not just for this revision of the project, but compare this project with some other BIM projects and see how many property issues other projects or similar projects had in specific period of time or in specific project stage. As I mentioned, using Portfolio, you can also analyze other key performance indicators of your project revisions, such as difference between planned and actual schedules and cash flows, various construction and cost analysis, or even earned value analysis. But I will talk about some of these reports later on when we explain schedule and progress entries. Another extremely important thing I want to mention is that Portfolio Manager has a project and user administration where administrators can manage projects, project revisions, and users. So project admins can see projects and project revisions with respective information who and when exported different project versions, and in the project user window, admin can add or remove user from the project using their emails. This is also the place where different roles and permissions can be assigned to different users, and admins can create or delete entire projects. Also, users can review the history of project revisions with the respective information, and admins can organize or delete these revisions as well. Again, these are current options, but as I mentioned before, all these services will become a part of our unified cloud-based Bexcel Common Data environment with more integration and collaboration options. The next part of workflow is, once we identify if there are missing properties using BIM checks, is to add missing or create new properties to BIM elements using our data enrichment add-in for automated model data enrichment. It means that using customizable Excel templates, you can add new information as new properties to BIM elements. This method is very useful in a situation where, for example, we need a classification codes added to BIM elements and design teams didn't provide it or it's not fully implemented. This add-in, as mentioned, also using Excel templates with predefined properties to automatically add new properties and property values to model elements based on specified rules. Again, very simple template. In the first column, we need to specify element categories or IFC entities, and then based on next few columns, which are used as rules, the system will add new properties and their values. In this case, system group name and the structural elements are properties used as rules, and their values will define what will be the value for two new properties for DIN 276 classification code and description that shall be created. Today I will use a bit more advanced template that is using 8 different properties as rules, and based on them, entire property set Bexcel added and 2 new text type properties with the respective values according to uniform classification will be created and added to BIM elements. After a short loading process, everything is completed. Data enrichment add-in also creates smart selection sets every time we run it. And as you may see, entire list of all elements with added properties values. This can be used to check which elements got property values. And here we can also check if all elements are enriched. By selecting elements in the property window, newly added properties are visible. Bexcel Manager also have an online integration with buildingSMART data dictionary, so it is also possible to automatically download and add these properties to model elements. The process is very simple. To automate everything, I will use data enrichment add-in again, but this time all elements will be enriched with new property called BSDD code, and this code will be used to match model elements with the respective ETIM8 database from BSDD and enrich elements with the respective properties according to assigned ETIM classification. In property window, all elements got various BSDD code value according to ETIM classification. And now I will use load properties BSDD add-in to connect with BSDD database and select properties that we'll want to add to BIM elements. After completion, the system informs us that properties are loaded from BSDD service, and we can now explore all these downloaded properties added to different BIM elements based on their eTeam code. In the custom breakdown, we can see that different IFC entities now have different BSDD properties added. For example, beams, then doors, or slabs. Each entity has different properties assigned, and we can see the same for MEP model elements. Now when required properties are automatically added, we can again automatically or even manually populate different values for each created property. All added properties and their values can be exported from Excel Manager back to Excel files, or we can just export IFC file directly from Excel Manager, and all added properties will be also saved. This process map shows us a workflow for cost estimation using Excel Manager. There are two main approaches to BIM-based quantity and cost estimation in our platform, and one is almost fully automated, relying on information from BIM elements, where we can create a breakdown structure of elements based on their properties and then use it to make an entire cost classification. The second approach is using existing cost classification standards or databases and import them into Excel Manager. In both ways, system automatically calculates quantities and prices, so we can use it for further analysis. The first step to cost estimation is creating a quantity takeoff that shall be used as a work breakdown structure. To do that, all model elements will be included, and for hierarchy structure of quantity takeoff, again, we can use one of templates from the knowledge base. These are some available default templates. For any project, user can create their own templates according to any standardized classification and properties used in their model. The applied template just organizes quantity takeoff structure using property uniformat assembly code that we added previously using data enrichment process, and hierarchy levels are made by uniformat code characters, and in the last hierarchy level we are using IFC object types, since multiple types can have same uniformat code and we need that additional clarification for each item. Now we have entire work breakdown structure for our cost classification organized as we wanted. This quantity takeoff and its structure will be used to create new cost classification. To automate this step, I will use again creation wizard, and of course the other workflow is even easier. We can just import existing cost classification that we already have and use on different projects from Excel spreadsheets, formatted in the way that Excel Manager can load it. In this case, we will create entire classification from scratch using this wizard. The process is straightforward. First, I will select quantity takeoff that will be used to create cost classification. The next option is used to choose how cost classification items will be coded and how classification items will be named. So for this purpose, we can also use naming templates that in this case will provide name and description of classification item. It is another very simple Excel spreadsheet that you can create or create new ones that are exactly suited to your company specific or market specific cost classification. The next group of properties that we have to define is coding system for cost items. So if you remember, when we created quantity takeoff, last level of hierarchy was IFC object type, but since these elements are almost always project specific, we usually don't have a coding for them. So in that case, our system will automatically create coding for each cost item using customizable schema that shall add suffix to already used uniformat code. For the name of each cost item, I will again use quantity takeoff. So initially, name of each cost item will be according to different IFC object type names. In case that we are usually making some standardized or prefabricated buildings, we could make a template for this as well. And the last part is to define the rules of measurement, or to specify how the system will calculate quantities and prices of all model elements. This is another place where we can use templates from knowledge base, and in this Excel the logic is similar to what we already have in previous uses of templates. In the first column we have IFC entities or model categories, and based on a few properties from other columns we can tell the system how to calculate quantity and price. So for example, for all cable trays, the quantity formula will be length and unit will be meters. Using this advanced sample from our knowledge base, in case of, for example, slabs, we can specify that different calculation formulas and quantity type should be used if the slab is structural. And not just that, our algorithm can even create additional sub-items for this cost item and calculate quantities for reinforcement, formwork, and concrete pouring for elements using different formulas and quantity types. This can be specified for all types of BIM elements, and by using this ability we can specify very complex quantity formulas. Of course, everything is completely customizable, and all of this could be used just as instant out-of-the-box template, or you can create your own customized templates. The structure is completely reflecting our work breakdown hierarchy as defined in quantity takeoff. It uses uniformat classification, and you may also see the system created separate classification and cost item for this case reinforcement, formwork, concrete pouring, and concrete finishing items, and each of them has different calculation formula as we specified, and each of them will be in this case assigned to the same elements, so we don't have to model reinforcement or formwork, since the system will rely on the existing concrete elements and calculate them differently. Remember that we instantly created classification, but we still need to specify resources or unit prices for each cost item. We can define all this information right here within the system by providing prices for different supplements or actual resources. Or another possibility is to export created cost classification to Excel files. Exported Excel file is sometimes easier to modify. The exported classification is the same, with the same information as in application, but sometimes it's much faster to populate cost or resource information in Excel. Users have the same options available and possibility to populate supplement price from the market, or to really specify prices for each resource and get into details of each unit price. Now I will show you fully loaded cost classification with all cost item and resource information populated. Each cost item has updated values for labor, material, and supplement cost, and even prices for different resources are provided, so entire project analysis will be more detailed and accurate. If we go back to the application, we can simply import this populated cost classification from Excel. User can actually decide and update the existing cost classification, or to create new one and later compare the price differences between different cost versions. In this case, I will just update the existing one. All cost items are updated, and as you may see that even resources and daily outputs are specified for each cost item. Now the project is ready to create cost estimation using another tool for automated cost calculation. By applying auto-assign command to system, the system will automatically assign B-model elements to created cost classification. The computer algorithm will go through each model element and find all elements that are corresponding to a certain rules defined in cost classification. It will calculate quantities based on defined calculation formulas that we have defined, and of course multiply it with the unit prices and create what we call, or what we can define as a project budget or a bill of quantities. The process is more or less completed in 10 to 15 seconds for a model of this size. So the assignment process is complete. We can go to the assigned items, where we are able to review entire project. We can review entire budget, which is auto-generated with specified price for each cost item. In this case, each cost item price is also broken down by material cost, labor cost, and equipment cost. And in some cases, we can also specify subcontractor cost for some cost items, where we had additional cost information for subcontractors. Since everything is integrated, we could select items directly from the list, and respective elements assigned to cost items can be visible in the view. It also works in the opposite direction, so selecting any model elements system can in the view, the system can show us the cost items, quantity, and price. This time we can export 5D estimation dashboard, because that report covers complete cost information of the model. And of course, in our next update, this functionality will be improved, integrated within common data environment, and user will be able to just simply choose model revision from the drop-down menu. The next step allows us to choose cost version from the project that we want to publish, and it is really up to user or to export one or choose multiple cost versions that they want to export online. The last step allows us to choose which custom breakdowns we want to export, so these can be used for different color coding within the Power BI reports. When the export is completed, we can open Power BI dashboard, and the first thing to do is refresh all exported data. The next thing is selecting one of exported cost versions in the drop-down, and all tables will be populated. We can also select the color scheme available from breakdowns, but this will be available once the model is loaded. To do that, we just need to publish this report online, and then if needed to share report with other participants of the project that doesn't necessarily using our common data environment, we can generate a public web link. Once the dashboard and the model are loaded, we can again choose between exported cost version if needed, and we can change custom breakdowns that will be active. Based on active breakdown structure, the model elements will be color coded differently. On the right side, we have ability to quickly filter elements by groups of works, and to visualize the elements of only specific group of work. User can select multiple groups of works, and whenever a cost item from the table is selected, model elements are clearly shown in the Excel viewer, and at the same time all the charts are updated according to selection. Cost of the labor, material, equipment, all the resources related to certain elements, and all the charts are showing to which source these elements belong to and in which group of works they are assigned. These charts are also showing what is the structure of these cost supplements and resources within selected elements. Another very important and unique feature of Excel Manager is that cost information is integrated to the lowest level of hierarchy, or to be clear, to the element level. This means that if you select any of the elements of the model, you're gonna see exact quantity, exact price, exact resources, and all other parameters for that specific elements or group of selected elements. So when we're selecting multiple elements, all the parameters in the dashboards are changing at the same time. As mentioned before, we can also change the coloring scheme, so entire model can be color coded by the group of works. If, for example, domestic water distribution group of works is selected, all elements included in this work group will be isolated in a view, and at the same time we can analyze cost and quantity distribution of these elements in different building areas. Also, necessary resources for this work group are presented in the charts. The same can be done for any different work group, for example, a system of the same can be done for different systems or work groups, and the system interactively and instantly will be changing respective information for these selected elements in the view. It gives us a lot of flexibility for visualizing the data in the model, and we can even try to combine multiple filters and isolate specific structural elements on specific building level. I think that you already understand the potential and possibilities and different uses of these kind of interactive reports. The next important BIM project workflow is related to planning and scheduling, and therefore we have a unique intelligent scheduling approach that again enables automated process of creating schedule instantly related to respective model elements and cost classification or cost estimation. The process relies on already created cost classification, and now planners only have to specify spatial zones and sequencing logic between different work groups, and scheduling engine will automatically create initial schedule by crossing these work sequences and building areas where the system recognizes these activities based on link BIM elements and cost items that are related to them. As I mentioned, the process is automated if necessary steps are followed. Firstly, spatial project organization has to be specified, and it's done using zone editor. Relations between spatial project zones are created here using selection sets. In this specific project, we used selection sets for buildings, then for different project phases. As you may see, the planner can refer to model in the view and have better understanding of construction phases, and then make logical relations between different phases. Similarly, building levels and relations of sequence of execution of activities through building levels can be set within the zone for building levels. Once the sequence and relations between these zones are made, the next step is to specify the order of all activities. An entire sequence of activities can be created from scratch by linking to existing cost classification and cost items that shall be instantly used as respective placeholders for our schedule activities. It is very intuitive and simple to make logical relations between these items, but since groups of works and their sequence and relations between them in common construction schedules are more or less typical, or at least for certain types of projects, in this case I will, for this specific common high-rise residential building, I will import already prepared construction methodology from previous similar project and gonna reuse it again. Of course, certain adjustments are always needed, but it still gives us more time for further optimization when the initial schedule is at least created. Creation template is the place where user can define level of schedule organization and their hierarchy. The computer algorithm then generates actual scheduled tasks and relations between tasks by spreading down all activities through zones in which activities are recognized according to BIM model. The entire schedule is created using location-based planning, and since on this demo project I tried to create construction zones in a way to each project zone contains almost equal working areas, so they can be executed with almost equally distributed resources. Therefore, entire line of balance, which is also immediately available, shows us that our scheduling algorithm created initial schedule already trying to distribute activities as continuously as possible. If needed, we also have available additional options or more advanced options for fully or semi-automated schedule optimization, taking into consideration daily outputs or resource availability. In this task report, we have more instantly available information such as cash flow and S-curve for one or multiple tasks. Here we can analyze activities and resources and their allocation in detail. As you may see in this task report, activities are optimized and resources are more or less equalized. The same task report analytic is available for one task or for a multiple task. In this example, we are actually looking to cash flow for one building and for entire project in the corner. The same thing here for S-curve showing our cumulative cost for one building and for entire project. Finally, when the schedule is created, the entire construction simulation is also instantly available. And since all BIM elements are at the same time related to schedule and cost estimation, we have all information available in this video. Since everything can be synchronized with our online environment and common data environment, we can publish the project online, and within the online viewer we can also review construction simulation without need to even use a desktop application. This is now available for all users with respective credentials to access using mobile devices and web browser. When it comes to progress monitoring, once the baseline construction schedule is created, our system can also generate look-ahead plans or other template files that can be sent to construction site using a cloud-based platform. On-site members can make progress reports using BIM elements that representing executed works, and then this information are sent back to the office where progress entries are being reviewed, confirmed, and entered. Once the progress entry is added, the actual schedule is being updated and all changes are reflected in respective cost and quantity information. This animation shows us optimized baseline schedule in the application, and these simulations can be shared as exported images, videos, or through an online view as you have already seen. The first step in the progress monitoring process is to prepare look-ahead plans for specific construction period and provide it to the site team. Using our API console and available template scripts, we can automate this process as well. Scripts are quite simple and you don't even need programming knowledge to edit and use them. For this exercise, I will use the one that generates selection sets of elements planned to be executed from the last progress entry date. We can also use a variation of the same script where interval duration and interval counts can be changed for more customizable look-ahead selection sets. Another interesting script is the one that generates multiple selection sets for entire duration of construction simulation divided into specific intervals. Commonly used intervals are day, week, or month. Daily interval is the most detailed one, and it will group all elements executed for each day, and monthly will create monthly selection set for each month of execution. This selection set can be later used for construction simulation in our online viewer. Now we can go to selection sets and see results of these scripts. The first one created selection set for 1 month, in our case look ahead for 7 months of execution, and all tasks planned for that month are organized into selection sets by task name and activity name. In selection set folder called schedule animation selection set, we can explore results of the second script, the one that will be used for schedule animation within the viewer. Any of these created groups can also be shared using an openBIM collaboration format or directly by uploading selection sets from Bexel Manager to online viewer. Firstly, I will use BCF Manager within Bexel Manager and just drag and drop selection set here. As you may see, I also have saved BCF issues for each previous look-ahead plan in the past 6 months, and these can be directly shared online or can be saved as a BCF files. At this moment, we can load BCF files in our online viewer, but very soon we are planning to also make a live connection between online viewer and Bexcel Manager for synchronizing BCF files and selection sets automatically. Now when we have entire project with look-ahead selection set saved, we can share all this information by publishing entire project to online viewer. I will publish it using this option, and when we go to provided web link, this is how the loaded model looks like. All selection sets are available in desktop application, and using animate option, we can animate those selection sets that we generated from schedule animation using the script. Using cloud-based online model viewer, site managers or subcontractors can easily review entire project using mobile devices on the site, and they can use this existing information and element groups saved as selection sets or BCF files as some kind of guideline for construction works that's supposed to be executed and approved on site. So they can easily isolate elements planned to be executed next month directly from selection sets, or these elements can be also selected and isolated by loading previously received BCF files. Once when construction activities are executed, our site team can update provided selection sets and mark executed elements. All other elements which are not executed can be hidden, and the entire process can be done on a mobile device, and then site team can save these newly created groups as another BCF file or completed works and send it back to the project manager or office teams for revision and final certification. An office team loads BCF file containing executed elements, and these elements can be visually reviewed, and it is always good practice to save them in the way that we can have entire history of all previously saved executed works for each previously entered progress. Another good practice is to duplicate an existing schedule before making a new progress entry, so we can always review different schedule options, track history of schedule changes, or make advanced analysis of different schedule versions against each other. For entering progress information received from the site and updating the actual schedule, the easiest way is to use our intelligent progress entry editor. This tool allows us to at the same time review the model and progress entries. So simply by selecting progress entry on the left side or activities on the right side of this window, the system is selecting elements related to these tasks which are added in each progress entry. In our case, we already have progress entries for 6 months, and we can easily find respective elements. The elements can be selected even for multiple progress entries, for example, last 3 months. And the summarized cost of these works is also visible in the top row of this window. On the right side, we can switch and see task, activities, or classification hierarchy of all works executed in each selected progress entry. This gives us even more flexibility to accurately add and confirm executed quantities and to confirm spent price during their execution. On the right side, you can see each task and activity added in progress entry and information about total quantity and price, working hours spent for execution. Also, you may see information of executed quantity and remaining quantity in quantity units and percentages. And using different grouping, this information can be reviewed by scheduled tasks, activities, or by cost items related to these activities. Now I will make a new progress entry for 7th month of execution. Based on BIM elements from selected group provided from site, our engine recognizing all tasks and all activities in which these elements from selection sets are supposed to be executed in that marked time range. Based on quantities of these selected elements, system also calculates and populates actually executed quantities for each task. In the same way, percentage of completeness is also calculated for each task. During this process, a user can always switch between different view modes, and one to review activities for the previous period, and the other one to review all tasks, and no matter what view are selecting, all respective information will be shown accordingly. This gives more time to managers to additionally review and confirm if these tasks, quantities, and percentages are reflecting the real picture from the site. These values can be approved or they can be changed before final approval of executed works. Also, if project managers have information from contractors or subcontractors about real resources used for execution of each activity or each task, this information can also be populated and adjusted according to real use on the site. Just for the exercise, I will select specific activities such as reinforcement of footings and change resources spent for only these tasks or activities. I will increase used labor and also the quantity of spent material as well. And by doing that, we are telling the system that we had some unexpected expenses due to any reason. By changing resource quantities, the system will recalculate actual cost and all respective information and performance indicators such as, for example, earned value, cost variance, cost and schedule performance index, and similar. When progress entry is made by updating the last entry date, it is now very easy to compare actual and baseline schedule. I will just pop up this window so we can compare it with the baseline and analyze some of available information. We can check some key performance indicators such as baseline and actual cost, earned value, cost variance, cost performance index, or we could add more columns here, for example, schedule performance index, which gives us real information how close the project is being completed compared to the baseline schedule. All these information are instantly updated for each task after each progress entry. So now for any selected task, we can analyze executed quantities for each activity, actual and remaining quantities, actual and remaining cost for resources, and also for quantities of resources used for execution. In task report, all these information are visualized in form of cash flow, S-curve, and we can check comparison for material, labor, and equipment. The same can be done for entire schedule or, for example, just for one building in this case, where blue ones are actual information and greens are baseline information. In the S-curve, the same information are available, while in the material chart we can see filtered materials just for reinforcing steel distribution for actual and baseline schedule. One of the benefits of integrated system is the ability to export all information directly to Excel or share it with relevant participants of the project. There are a few other ways for information exchange, and one of them is exporting Power BI reports into customizable Power BI templates, providing all previously seen information, including an embedded online viewer, as you already saw. For this exercise, I will choose to export earned value analysis. At this moment, I will paste the same link of the previously exported online viewer model, but as I've said, we already made integration with our common data environment, so users can just select the already exported model viewer from the list of the online projects. From this window, user can choose the information that will be exported. In the case they want to perform more advanced analysis and compare multiple schedules between each other, and additionally, you may choose if you want to apply some color coding rules in Power BI, creating or applying custom breakdown hierarchies. I will export all this and then save the file. Exported Power BI dashboard template for earned value analysis is exported, and I have already refreshed all the data and everything is loaded. Just to demonstrate how the entire process is simple, I will actually publish Power BI template online and then check the results with entire model viewer embedded and visible. I will now open this dashboard. Since this is a free template, it is already organized in a way that everyone can easily read and understand presented data. The embedded view shows us model, while on the other side we have indicated status date and all calculated key indicators such as actual cost, earned value, cost variance, and more. S-curve shows planned and actual cost and planned and earned value. After the last entry date, actual cost line is flat since we still didn't make progress for that period. On the bottom, all tasks and activities are listed with respective information for quantity, cost, and earned values. Values for performance indicators are only changed for activities that have progress entries, in our case mainly for substructure works. In the middle, you may see how the schedule performance index and cost performance index are changed during the execution, and basically we were spending more money than planned before May, while in the last 2 months our expenses are okay. While at the same time we are performing slightly behind the schedule, and in the last 2 months we are improving, and now we are even ahead of baseline. Practically the same info is shown in the cost and schedule variance graphs. On the left side we have cash flow by months, and the greatest thing is that everything is connected and interactive. So if we select cost for July, for example, in the view, all elements executed by the end of that month are presented, and all respective data is changed so we can see cost items and tasks related to them. By changing color coding schema from custom breakdown, elements will be colored according to different information, in this case by construction zones. We may even select multiple months in our cash flow, and in this way we can see all executed activities from the beginning. Their key indicators and colored by zones. And if we had subcontractors breakdown, we could even select elements by subcontractors. In the list of all items in this period, we can analyze quantities and cost by selecting any of cost items, and respective elements are filtered in 3D view. These are core walls that are still not executed, and you may see only planned cost and quantity information are available. Even here, by selecting multiple months after status date, we are basically making look ahead of elements that shall be executed in selected period. Since I also selected the last progress entry months, we have planned and actual values visible as well. Since information for each element are exported, we can even select elements in a 3D view for core walls one by one, and the dashboard will change all relevant indicators only for them. But since core walls are still not executed, we only have planned values. Again, we could change coloring mode and color model by uniformat codes if we need to analyze specific items in more detail. For reviewing executed foundation works, we could select only uniformat A classification items and then select the ones we want to analyze, for example, foundation slabs. And as I'm selecting it, we may see if we are making profit by executing these elements, and also if we are ahead or behind the schedule. So these types of reports have great value for managers and executives. The next Power BI dashboard is very comprehensive and is mainly intended to be used by subcontractors or cost and project managers interested in very detailed analysis related to each resource used in construction. Again, in the middle of report we have embedded online viewer, while on the sides we have multiple charts dedicated to material on the left side and labor on the upper right side, while main key performance indicators related to equipment are visible in the lower right quadrant. Each table contains listed resources of respective type, and each column we have calculated values for cost, quantities, performance index, and so on. Again, these charts are very advanced and detailed, and we can use them to help subcontractors to understand their performance and optimize their processes in order to eventually achieve more profit. Since everything is interactive by selecting any resource item in the charts, the elements related to activities where respective resources are used will be also shown in the view. At the same time, all charts are being instantly changed based on information from selected elements, and we may explore, for example, some executed structural elements and see these results. This progress report Power BI dashboard is just another example to show you the potential and possible use of available data and how we can even compare baseline schedule in the left view with the actual schedule in the right view. Similarly, as in a previous dashboard, by selecting any chart item or cost items from the tables, instantly all information in charts are updated and related elements are selected in a view. So we can review some of executed structural works. Again, all the data for all these dashboards are extracted from exported files, and it is more or less the same. These are just the templates that gives you idea how you can differently present and report all this available information by creating different reports. The last example is payment certificate template that contains typical payment certificate sheet containing columns with planned or contracted quantities and cost, while in the other columns, as a result of progress entries, we have information about summarized total quantities and cost for executed works until certification date. We have cost and quantities executed during certification period, which is usually 1 month, and we have remaining quantities and price to complete construction. Since everything is connected, for each model element, we can see information presented in a table or in chart. Beside Power BI dashboards, another useful way to publish and share all important project information is using our cloud-based portfolio manager. I will use Publish to Portfolio Manager tool and export current project and its latest revision online. When the data is published, I can access our online platform and see results using web browser. This online platform is created to collect all the BIM data from multiple projects and multiple revisions of any project, and all data is saved on a cloud-based common data environment, and entire platform is very flexible and interactive. Another important thing I would like to mention is that all data can be accessed using Bexcel REST API, and this way the number of possible customization of or integration of Portfolio Manager with other application is almost unlimited, and you may create your own information exchange ecosystem using it. For the end, I would like to briefly introduce you to our unified cloud-based common data environment for our users. This will definitely change information exchange workflows and hopefully will become a real single source of truth. Entire cloud-based platform will be used to create, access, and manage all projects and use our online services, and of course based on users' credentials. Another big step in our development of cloud ecosystem related to our products and workflows is also a project asset management and facility maintenance. As you already knew, within Bexcel Manager FM desktop modules, users were already able to create maintenance plans and respective cost estimates, and also it was already possible to link all relevant project documents directly to model elements or to FM plans using an integrated cloud-based document management system, and entire cost estimation for operation and maintenance period could be also tracked, and progress entries could be made directly from the site using mobile devices. All data is initially created locally on your desktop application or using mobile devices and then synchronized with our cloud-based application. Now, using Bexcel Common Data Environment, entire asset management and maintenance process is even improved and elevated even more. So I'm delighted to introduce you one of the most requested and awaited features related to asset management, and that is full implementation and connection between Bexcel Manager cloud-based facility maintenance application and our online model viewer. User interface, as you may see, is very similar to the one in the local application, and all functionalities are the same. But now users with the respective credentials can use any mobile device and can access to it and explore maintenance plans and the model as well. Online platform is web-based and data is cloud hosted. All created information are synchronized and updated between this cloud-based and remote Bexel Manager application. And as you may see, everything is interactive and user can easily find all assets that are related to specific activity instantly in the viewer. All FM plans can be reviewed and edited, and any related document can be also viewed using mobile devices. Additional documents or screenshots can be added to FM plans or to the model elements directly, and for each FM plan, user can set notification that will inform respective company to execute their activities on time. Filtering of FM activities and related model elements in a viewer is bidirectional, and user can easily identify activity and all relevant information by selecting any element in a view and vice versa. Important thing is that we are now leaning toward full level 3 BIM implementation by shifting our processes online, and we also believe that all presented cloud-based services are just one big step forward and our contribution to the implementation of BIM level 3. At the moment, we do have available and operating online services for FM, as mentioned before. From recently, our online model viewer and online portfolio managers are functional and operating also. And new improvements for these services are being added, and respective options for user management and administration as well. In the upcoming period, we plan to progressively enable all set of Bexel Manager cloud-based services that shall be merged together. It will also include the entire cloud-based document management system, also with project and user administration. All that will practically enable users to explore all Bexel Manager projects, revisions, and documents, along with the access to entire project and documents history and possibility to compare multiple revisions of these projects and documents as well. The entire workflow presented today with integration of cloud-based services in the future will be entirely, possible and available through our online services, and all the processes will be in a way translated from local computers to online, allowing you to simply explore projects and results using your mobile devices without using desktop platform. I hope that this gives you enough information to understand possibilities of integrated approach and outcomes of synergy between automated workflows and cloud-based solutions. And on the other hand, this is just the beginning of BIM Level 3 implementation, and we are looking forward to it. That was all from me for today. Thank you for your attention. Good afternoon, everyone. Thank you again for your time. I'm very sorry that unfortunately I wasn't able to be there in Montreal with you in person, but hopefully we will meet in person next time. Yeah, I see the question. And if we talk about file size, practically there's no limit in a number of IFC files that you can load and number of the elements that can be federated into project. The only limit is your hardware, and we actually managed to open hundreds of IFC files on our infrastructure projects, and also to work with more than a million of BIM elements at the same time. Sometimes in these cases, it may just not be smooth or responsive as it could be if you work with a smaller project, but you can always decide to hide some of the elements and review large projects partially. And if we talk about data or information that can be exported from Bexel Manager, Again, we didn't have any limitation in the application. The only limit was when we tried to export data into Excel spreadsheets. Excel itself has a limit of number of rows that can be exported, but if we're using SQL databases or JSON files to export data, there's no limit. Well, I'm not really sure if I understand this question correctly, but if you think about if these elements that you are loading in the project are geolocated, it depends on the let's say authoring tool that you created your projects initially. So if you created and geolocated your elements in the authoring tool, then these gonna be located in the same place when you load elements in our platform. Yes, we do. And there are, if you talk about these large scale projects, if the elements are located, um, let's say, in a distance which is more than 20 or I believe maybe even 50 kilometers from the original coordination point, sometimes we do have some, let's say, um, visual problems or geometrical data is not accurately presented, but it's not just the problem of our platform. It is a common problem in almost all platforms. So in these cases, I would suggest to uh, partially review these kind of projects. Difference between manage driven and automatic and data driven. Well, basically in our case we have almost entire project which is uh, automatically or data driven, because all analysis that you can perform in the Bexel manager can be automated in a way that we are using templates, and these templates are actually fulfilled with the different types of data. And if you just using manage to let's say populate information in the application, it means that it's still not fully automated process. Managing it could be different type of management. It could be also automated, but it also can be manual. But if we are using, let's say, data or automatic driven process, then everything could be more or less automated and streamlined through entire process. And how to store, I'm not really sure to store what exactly. If you talk about all information are stored within our platform, and if you export all the data, everything is stored on a cloud-based servers as well. So everything is stored in one place. It's a let's say single source of truth, contains geometry and data, and these data can be organized in order to extract informations that are needed for our current scope of work. Thank you all again.